All right, welcome to The Explainer. Today, we're diving headfirst into a world where science fiction is quickly becoming science fact. The incredible merging of our own biology with digital technology. That line between what's human and what's machine, it's getting really blurry really fast. So let's get into it and figure out what this all means for us.
So let's just kick things off with this really powerful idea. Look, we're not just talking about cool new gadgets here. We're talking about something that could fundamentally change how we see ourselves. It forces us to ask a pretty huge question. What does it even mean to be human when biology and technology aren't two separate things anymore? For most of human history, we've drawn a very clear line in the sand. It's always been us, humans, on one side, and then everything else, including our tools, on the other. But new ways of thinking and, of course, new technologies like AI are starting to erase that line. They're making us wonder if our consciousness, our intelligence, is really as exclusive as we've always believed.
Okay, so to really wrap our heads around this huge shift, we need a name for it, a framework. And that framework is called biodigital convergence. Honestly, it's the key to understanding everything we're about to talk about. So, what is it exactly? Well, at its heart, biodigital convergence is the fusion of living things with digital systems. You can almost think of it like biology and computer code are finally learning to speak the same language. And as we're about to see, that conversation is going to change pretty much everything. How we live, how we work, and yeah, even what it means to be us. And this is happening in basically three big ways, all at the same time. First, you've got the physical stuff, literally putting computer chips in living things or using biological parts in our machines. Second, there's this coevolution, where a breakthrough in digital tech sparks a breakthrough in biotech, and that sparks another digital one. It's a feedback loop. And third, and maybe the weirdest one, is this conceptual shift, where we just start to think about our own biology as a kind of code, and our technology as a kind of living thing. And check this out, because this slide really nails that third point. On the left, you got the beautiful, organic spiral of a sunflower, and on the right, you have the cold, engineered logic of a circuit board. But look closer. They totally echo each other, don't they? We're starting to view biology like it's an information system we can edit and manage, while our technology is getting so complex, it almost behaves like its own living ecosystem. Okay, so let's zoom in from this massive, big picture idea and get personal. Let's talk about plugging technology directly into the most complex thing we know, the human brain. This is where it gets real. The tech that makes this happen is called a brain-computer interface, or a BCI for short. Basically, it's a direct hotline from your mind to a machine. It reads the electrical chatter of your thoughts and translates it into commands, letting you control a computer or a robotic arm just by thinking about it. No muscles required. So how do you actually build that bridge into the brain? Well, you've got two main options, and there's a huge trade-off. You can go non-invasive, which means putting sensors on the outside of the scalp. It's safe, sure, but the skull kind of muffles the signal. It's like trying to eavesdrop on a conversation through a thick wall. Or you can go invasive. That means putting tiny electrodes right into the brain tissue itself. The signal is crystal clear, but as you can imagine, that comes with some serious medical risks. Now, let's take a quick look at how we even got to this point, because this stuff didn't just appear overnight. The journey really started 100 years ago with those simple EEG caps. Then, fast forward to the 2000s, and you have the groundbreaking BrainGate system, which let paralyzed people control robotic arms. More recently, we've seen clever, less invasive approaches like the stentrode, which travels through blood vessels. Every step got us closer, but every single one had major drawbacks. And that whole journey, that steady climb, brings us right up to the bleeding edge of BCI technology, a project that's trying to blow past all those old limitations and trade-offs that have held the field back for decades. So to really get why this next step is such a big deal, you have to understand the problem it's trying to solve. See, with those older invasive implants, you had this major issue. The brain is soft, it moves around in your skull, but the electrodes they were using were stiff and rigid. That mismatch created scar tissue, and over time, the body's own defenses would just wall off the implant, and the signal would fade to nothing. And this is the genius solution. Instead of rigid spikes, Neuralink came up with these ultra-thin, flexible threads. We're talking 4 to 6 microns thick, way thinner than a single human hair. They're designed to be biocompatible and flexible enough to just move with the brain, which dramatically reduces damage and makes the connection last so much longer. And this is the key takeaway, right? This isn't just a small step up. By using literally thousands of these tiny threads, Neuralink is going for a massive jump in what we call bandwidth, the sheer amount of information that can flow between the brain and the computer. Seriously, it's the difference between ancient dial-up internet and the fiber optic cable running into your house today. It's a whole new level.
And the way they do it sounds like something straight out of science fiction. First, they make these tiny threads. Then, and this is wild, a custom-built surgical robot, one that's precise enough to dodge tiny blood vessels, carefully sews them into the brain. From there, the implant chip reads the neuron activity, cleans up the signal, and beams it wirelessly to a device. It's this incredible dance between material science, robotics, and neuroscience.
Okay, but a technology this powerful, this intimate, it does way more than just solve engineering problems. As this stuff moves out of the lab and into the real world, it's gonna force us to ask some of the biggest, most profound questions we've ever had to face as a species. I mean, think about it. If an AI gets smart enough, does it deserve legal rights? If your thoughts and memories are backed up to the cloud, where does the real you even live anymore? How do we make ourselves better with technology without losing our own free will in the process? These aren't just late-night dorm room questions anymore. They are the very real dilemmas we're about to face.
Now, there's a whole school of thought called posthumanism that looks at all this and says, hey, maybe this isn't a threat at all. It argues that human was never this fixed, static thing. I mean, think about how we talk. We say my hands, my eyes, as if we are the consciousness using these biological instruments. Posthumanism just says our identity has always been fluid, always evolving with our tools, from a stone axe to a smartphone, and now to a brain-computer interface. So from that point of view, this isn't the end of humanity, it's just the next chapter.
And really, that's the question we're all left with. This technology is forcing us to decide who and what we are. Are we a fixed point, the final product of millions of years of evolution, something to be protected at all costs? Or are we just the first step in a much, much longer journey, destined to merge with the very things we create? The biodigital future is coming, and that's a question we're all going to have to answer.